Sine rule, fantastic, but it doesn't cover every possibility. So we also have the cosine rule. Basically, it's Pythagoras Theorem on steroids. Drop in the perpendicular. This time, I'm going to use Pythagoras Theorem. So h squared would be b squared minus x squared. But also, c squared, using the other right angle triangle, would be h squared plus a minus x all squared. Well, the h squareds must be the same. So if I substitute the b squared minus x squared, we get c squared is b squared minus x squared plus a squared minus 2ax plus x squared. Now let's play around with that. We get b squared plus a squared minus 2ax. X over b is the cosine of c. So I can now get rid of the x. And I come up with our cosine rule. As I say, Pythagoras' theorem on steroids. Because essentially that's what it is. There's Pythagoras' theorem. C squared equals b squared plus a squared. But we have this additional bit of minus 2ab cos c. The reason it's Pythagoras' theorem, in Pythagoras' theorem we're using right angle triangles. So c would be 90 degrees. And the cosine of 90 is 0. So that part disappears. And you're just left with c squared equals a squared plus b squared. So in any triangle, a squared is b squared plus c squared minus 2bc cos a. So the additional bit, again, it's two sides and the included angle. So same as when we find the area of a triangle. That's what you're looking for. So I could have b squared is a squared plus c squared minus 2ac cos b. And c squared is a squared plus b squared minus 2ab cos c. All possibilities. Let's do an example. So for this one, it's t that I want to find. So t squared would be f squared plus m squared minus 2fm cos t. I've got two sides and the included angle. This will work. Substitute in. Be very careful. Remember, you're finding t squared here. So you are going to have to find the square root of this answer. Often people, well not often, but a common mistake I guess, is people just write the t squared down. They forget to find the square root. So t, I've done it to the nearest whole number, again just matching the question. So 8 units it would be. Now if I want to find the angle, so remember two sides and the included angle. So it would be f squared is a squared plus s squared minus 2as cos f, because they are the two sides and the included angle, as, and the angle is f. Now some people like to rearrange it and make cos f the subject. Not a bad idea. Some people just memorise the formula that way. That works too. Remember, these formulas will be on the reference sheet as well. If you ever do have a mental blank and go, oh my goodness, what's the cosine rule? You can always look it up on the reference sheet if you need to. Substitute in. Now the lovely thing about the cosine rule is it will give you obtuse angles because cosine is negative in the second quadrant. So if this fraction here turns out to be a negative number, then I know I've got an obtuse angle. And so you can tell that straight away from the top of the fraction. 6 squared plus 15 squared minus 20 squared, is that going to be positive or negative? You can do a quick check. And in fact, yeah, it is negative. We've got an obtuse angle there. Makes sense as well that that one would be the obtuse angle because look, it's opposite the largest side. So there's a chance that that was going to be obtuse. Now I said you need two sides and the included angle. This one isn't that situation, but I can't use the sine rule either. I can use the cosine rule though, and here's how I do it. I just treat it as the included angle that I know is A. So I act like I'm finding the side A, the one opposite. So A squared would be B squared plus C squared minus 2BC cos A. Substitute what I know. And what I've ended up with is a quadratic equation in terms of B. So make it look like a quadratic. B squared minus 14b cos 25 plus 40. I can put that into my quadratic formula. Now I've got two possibilities here though, because of the plus or minus. Without more information, I don't know which one of these answers is right though. 5.85 or 6.85. Well, if I knew some other information, I might be able to tell which side's the biggest side and things like that, but I don't have enough. So two possibilities, unless they give me more information, I could narrow it down. Let's do a 3D question from the 2003 HSC. David's in a life raft. There he is down here at D, the life raft. Anna is in the cabin cruiser up there at A. They're in contact by mobile phone. Practical question here. David tells Anna, who's now changed the way she spells her name, what happened there, that he can see Mount Hope From David's position, the mountain has a bearing of 109 degrees, because fortunately, he happened to have with him a compass and a theodolite and all this stuff, so he could measure this stuff. He could work out his bearing and everything, which was very fortunate in this life raft, let me tell you. From her position, it's got a bearing of 139, and top of mountain, 23 degrees. Find the distance and bearing of the life raft from Anna's position so she can go and save David. Okay, there's our diagram. Let's draw some two-dimensional triangles. I've got this one here. That's David's triangle. There's Anna's triangle. Now, we've been given some information about bearings. So the compass is on David, because David was the bearing, 109 degrees. Now, Anna, her bearing to Mount Hope was 139 degrees. So there's a third triangle I can play with. We're trying to find the bearing of David from Anna, so theta, but also how far away they are. So I want to find B as well. Okay, let's start putting some information in. I can find BD. BD would be 1500 tan 74. I could also find AB using a similar method, 1500 tan 67. And by the way, when you are doing this sort of thing, if you're going to do the exact same process, just with different numbers, you don't have to put all the working out down. You can just use this lovely word, similarly, that we use. Oh, similarly, AB would be this. Let's plonk that on our diagram. There we are. We now have two sides of our triangle. I want to find B. It'd be nice if I had an angle in there, and then I might be able to use a sine rule or a cosine rule. So what can we work out? Angle NDB plus DBN, so you'll notice I drew in another north line at B, because that creates a whole heap of parallel lines. I know they will add up to 180 co-interior angles. That gives me that DBN double dash, I called it, is 71 degrees. And similarly, I could work out ABN double dash, it would be 41 degrees. Now ABD will end up being those two subtracted. So ABD is 30 degrees. Let's put that on our diagram. We now have two sides and an included angle. I want to find B. Cosine rule should do it. Now, subbing it in, there's the lovely expression. You've got to be very careful when you put this in the calculator because of all the trig ratios you're typing in. But we end up with, to the nearest metre, 2,799 metres. Okay, we know how far apart they are. Now for the bearing. Got to find theta. Well, we know part of theta. We know it's 139 degrees up until the blue line. What's the extra bit? Okay, I'll use the sine rule for this one. So sine DAB, that's the one I'm working with. That's going to be sine 30 over the answer. And you'll notice I wrote B rather than 2,799 because 2,799 is an approximation. You might end up with a rounding error. So I actually want to use that calculator value that I got before for B, so just to make sure I've got it right. Okay, subbing that in, and remember it might be obtuse. So it's going to be one of these two. It's going to be 69 degrees 9 or 110.51. Now, if it is 69 degrees 9, then BDA would end up being 80 degrees 51. Angle sum of a triangle. But hang on, I know DAB has to be bigger than BDA. The largest side must be opposite the largest angle, the smallest side will be opposite the smallest angle. So that's no good. Therefore, it must have been 110.51. Okay, so if that is 110.51, I can add that 249.51. Okay. That shall do it.